Now there is a range. You have to have a subcooling of between 5 and some people say 7, but in some cases we say 5 to 10, because when it's at 7 degrees, difference in temperature between the condensing temperature and then the outlet temperature of the condenser. Yeah, the difference in temperature should be between 5 and 7. If you get 5 and 7, that is what we call normal condensation. Yeah, if you do take the temperature from here, the high side, which is the condensing temperature, and take a temperature from the outlet of the condenser, and you get, say, 15, or let's say 12, then that means the condensation is too high. And the reason could be that probably there is too much liquid in the condenser. Too much liquid in the condenser, so it's over-condensing. And when it's over-condensing, that can also affect your system, because you will have too much liquid going into the evaporator. Yeah? And that can spill over into the compressor from the suction side. So over-condensation is not good. You have to check that. And then under-condensation, if you do your temperature difference, you take the high side condensing temperature and then the temperature of the outlet, and you get, say, 0. If you get 0, that also means that the condenser is not condensing, it's under condensing. Now you can confirm it when you look at the temperature at the outlet, because that is where you can get the difference. You can see the difference clearly. For instance, if this one is a 16 and the temperature here doesn't go down, when this one goes down more, you get a bigger condensation. And if it doesn't go down and it's high, you might end up with equal condensation. I mean, you end up with low condensation, which is 0. Yeah, maybe 0 or 2 or 3. If it's below 5, then there is a problem. You know, but if it's 4, sometimes we say, let it go. But we know that the range is between 5 and 7. At the same time, when it's 8 or 9, sometimes we leave it, because it's on the borderline. Yeah, but then if you can get it perfect on the point, that is what we are looking for. Do you have any question on subcooling that you want to ask? Yeah, subcooling of the condenser, the importance of it. You can say if its condenser is bigger than the unit, it will overcondense. So you get high subcooling. Yeah? And if you don't get your subcooling at all, that is also not good. So because that will mean that probably there isn't enough refrigerant. Undercharge, yeah, or there is not enough refrigerant going through the condenser. And you know the effect it will have on the evaporator. You won't have enough refrigerant going in, and therefore the evaporator will not produce the cooling you want. You won't get the right refrigeration effect. And that in itself is a malfunction.
So if you
have to check it.
If you have a poor subcooling, then in effect you'll have a poor superheat as well.
You have a poor superheat as well. That's true.
So
yeah,
they're both connected in a way, aren't they?
They are related.
Related, yeah.
Yeah, closely related. So that is what. Now, if you overcondense and you don't check it, you end up with refrigerant going into the evaporator. It will absorb all the heat, but still it will have a bigger capacity to absorb more heat. So that means all your refrigerant will not boil off. It will not evaporate. Yeah, you get maybe 80% of it evaporating, 20% will remain liquid. And that liquid will spill over into the suction, and it will mix with the suction gas and enter the compressor and affect it. Of course, if you have an accumulator on the suction line, it can stop the liquid entering into the compressor, but then that doesn't mean that we should deliberately create that problem.
So it changes the temperature and not the state,
yeah? The condensation in the condenser, yeah, during the change in state, there's no change in temperature in the condenser. Yeah, it is only the refrigerant that changes from vapor to liquid. Yeah, so always remember that refrigerant temperature and pressure are constant in the condenser during the change in state, and that is demonstrated by what you see on the high side gauge. It doesn't move when it's running, and that is what happens here. But because sometimes it baffles people when you say the reading here is a condensing temperature here, that is why people dispute the the fact that there's no change in temperature. Some people say, no, it's not possible. Fan is blowing heat, out of the refrigerant, and now you are saying temperature is not going down. It's not changing. They don't believe it. But that is how it is. You can always get it from here when you compare. Okay, any more questions on subcooling? Yeah? Subcooling. Yeah? It's all about the temperature we record here. Yeah? That is what we call the bubble temperature. The bubble temperature means that it is recording the condensing temperature when the refrigerant in the condenser is 100% liquid. And that means the condensing temperature is what we call the bubble temperature. That temperature relates to the point where the refrigerant is all saturated liquid. That is not sensible.